So we will study first procedure oriented programming in C++. Procedure oriented programming. In this procedure oriented approach, the problem is viewed as a sequence of things to be done, such as reading, calculating, writing, etc. A number of functions are written to accomplish these tasks. The primary focus is on functions. The main characteristics of this procedure oriented programming is, first is the division into functions. So in this approach, a large program is divided into functions, and each function has a clearly defined purpose and a clearly defined interface to the other function, as shown below. So here a main program is subdivided into multiple functions, function 1, function 2, and so on up to function 8. So main program is divided into two functions, then function 1 calls function 3 and 4, and these two functions call function 7, and function 4 additionally calls function 8. So if you see, this entire program is divided into functions, and that is what is procedure oriented programming. Second is globalization of data. In a multifunction program, many important data items are placed as global so that they may be accessed by all the functions. Each function may have its own local data. Making data global allows any function to manipulate it, but this may result in losing any important information. So take this example. Here global data is there, and each function has its own local data. Third characteristics is that it is difficult to create new data types. In this approach, it is very difficult to create new data type like complex number data types, dates data type, etc. The property to create your own data type is known as extensibility. Therefore, POP are not usually extensible. Next is relationship to the real world. Another problem with procedural oriented programming is that it does not model real world problem very well. This is because functions are action oriented and do not really correspond to elements of the problem. Thus, the main characteristics of procedural oriented programming are: it follows structural programming approach. The approach being function oriented, data is given least importance. Globalization of data leads to loss of important information. It is not usually extensible. Don't model the real world very well. Programs are more complex to write and maintain. Modification and addition of new functions are difficult. Follows top-down design approach. So next category to look at is the object-oriented programming. This approach binds the data and the functions that operate on that data into a single entity. Okay, such an entity is called an object. This approach ties data more closely to the functions that operate on it and protect it from accidental modification from outside functions. Organization of data and functions in OOP. So if you see this example, object A, object B, object C, all these objects have their own local data and functions, and then these functions communicate with each other. Now we will see basic concepts of OOP. First is the objects. Objects are the basic runtime entities. They may represent a person, a place, or any item that the program has to handle. Programming problem is analyzed in terms of objects and nature of communication between them. Objects take up space in memory and have an associated address. Second is classes. The entire set of data and code of an object can be made a user-defined data type with the help of a class. In fact, objects are variable of type class. So if you see the above diagram, here we can say that A, B, C are objects and they are kind of a class where each class has a set of data and functions, and all these objects are variable of that class. Thus a class is a group of objects that share common properties and relationships. They are user-defined data types and behave like built-in data types of a programming language. Next is data abstraction. Data abstraction refers to the act of representing essential features without including the background details or explanations. Classes use the concept of data abstraction. Next is data encapsulation. The wrapping up of data and functions into a single unit is known as encapsulation. The data is not accessible to the outside world, and only those functions which are wrapped in the class can access it. Next concept is data hiding. The private parts of an object are not available outside the object and cannot be altered by external changes. This property of an object is called data hiding. Next is inheritance. Inheritance is the process by which objects of one class acquire the property of objects of another class. The advantage of inheritance is reusability. Reusing the existing code saves time, money, also increases the program's reliability. Next, polymorphism. Polymorphism refers to the ability of one thing to take many distinct forms. An operation may exhibit different behavior in different instances. For example, function overloading, operator overloading. Next is dynamic binding. Dynamic binding means the code associated with the function call is linked with it at a runtime. It is associated with polymorphism and inheritance. The main characteristics of OOP are: OOP is more data-oriented. Programs are made up of objects which model real-world problems. Data and functions are binded together in an object. Data is hidden and cannot be accessed by external functions. That is, data security exists. Objects may communicate with each other through functions. New data and functions can be easily added whenever necessary. It follows bottom-up approach. Benefits of OOP: reusability. Through inheritance, we can eliminate redundant code and extend the use of existing class. Data security. The data is not accidentally corrupted by external world like procedural oriented programming. Natural. Objects model the real world problems very well, and hence programming is quite natural. Creating new data types. We can create new user defined data types. Next is abstraction. One can use an object without knowing all its details. Object independence. It ensures that change to data and functions of an object can be made without affecting other objects. Software complexity can be easily managed. Object-oriented programming are easily maintainable. Easy to divide project work. Procedure-oriented programming and object-oriented programming. So here are few differences. That first is one is function-oriented, whereas other is data-oriented. There is no data security in POP, but there is data security exists in OOP. POP is not extensible, but OOP is. POP doesn't model the real world very well, but OOP does. Addition of new data and function is very difficult, but this is very easy in OOP. POP follows top-down approach, OOP follows bottom-up approach. Existing code cannot be reused in POOP, but it is reusable in OOPs. So next is scope resolution operator. Suppose there are two variables with the same name, m. Assume that one has been declared outside all functions, so it's a global variable, and another is declared locally inside a function. In C language, if we access the variable m, then we always access the local variable. We cannot access the global variable inside a function. Okay. C++ introduces the new operator called these four dots called as scope resolution operator to solve this problem. Syntax of this operator is four dots and variable name. Now four dots and m access the global value of variable m. We can see this by an example. Here we can see we declared a global variable m with value 30, and we then enter the main loop, main code of the program, and here again we have defined m as local variable with the value 10. Now first we printed the local variable m, and now to print the global variable m we use this scope operator, and then to reassign the value we defined scope operator m is equal to 50, and again we gave this print command. On giving the run, we see that first time local m was 10, global m was 30, and local m was again 10, and global m became 50. Next is inline functions. When we call a function many times, most of the time spent on various overheads like passing control from calling phase to the called function, passing parameters and passing control back to the calling place, etc. It is possible to avoid all this by making the function inline, using the keyword inline preceding its normal declaration. Inline function tells the compiler to replace each call to the function with explicit code for the function. Main advantage of inline function is that inline functions save the execution time, but there is memory overhead. If the function is called n times in the program, then it is copied n times, making the program code large. Example, suppose there is a inline function with float definition area, and it takes a float value r, and it returns 3.14 into r square. So and then we enter the main function, and we call radius and area a, and we then take the value of radius, and we put assign area by this inline, calling this inline function a is equal to area radius, and we then print out the area of circle. So on giving the run, we see radius equal to 1, The area of circle is 3.14. Next is the static data member. Static data members are data objects that are common to all objects of a class. They exist only once in all objects of that class. The static members are used when the information is to be shared. They can be public or private data. Whenever a static data member is declared, only one copy of that member is created for the entire class and is shared by all the objects of that class. The static data member should be created and initialized before main function. By default, the static data member is initialized to 0 when the first object of its class is created. So if we see this example, there is a class sample. It is count is declared as a static variable, and then we define public, which we will see in the later class. What does it do? Then we call the function a display. So we basically so now is the definition, like if we want to access count, so because we now moved out of the class sample, so we declared sample, which belongs to we declared count, which belongs to the sample class, and then we called or defined the display function, which was called in the sample. So which basically increments the count and displays the value of count. Now when we enter main, so we define that there is a sample class and there are variable s1, s2, s3, and then we called s1 display. So s1 display will then, first time there was a count 0, and like we have seen this in display class, it will increment the count and it will print it. So hence value of count is 1. In second time, again value of count becomes 2, and third time value of count again becomes 3. So if we want that we do not have starting from 0, then we can also give initial value to this static data member, like we call int sample scope resolution count is 50, which will assign it to 50. And then we call this class sample class display, sample class display, and we'll see value of count will be 51 and next run 52. Friend function. In an object-oriented programming, the data members declared as private in a class are restricted from access by non-member functions, right? Any attempt made directly to access these members will result in an error message during compilation. One way to access the private data by non-member function is the use of friend function. A friend function, although not a member function, has full access right to the private member, the class. We can declare a function to be friend of a class by using the keyword friend. So if we see this example, there is a class sample it has two variables a and b. It's again made public, so we call public so that all the variables are allowed to be accessed from outside as well. So we call as void set value. So here we have defined the value of a and b as 25, 40. Then there is a friend function of float type, which is the mean of sample class S. And then there is the definition of float mean sample S, which basically returns float type by giving S dot A plus S dot B. And when we enter the main function, we see that sample X is X. So we define X variable of sample class, then X called set value, and when we called set value, after that we print out, print out mean value is mean of X. So what it will do is it will take X. So if we can check in this example, so it will, so we by set value we initialize variable a and b as 40, and when we called sample S, or here we called the sample X, so it accessed a and b and did its addition simply, right, and printed out value 65. So what are the characteristics of a friend function? So first is, it is not in the scope of the class to which it has been declared as a friend. So if we see here, so the class, so float definition, or basically the definition of mean, is outside of the class sample. So by calling it as a friend in the sample, we are giving full access rights. Since it is not in the scope of the class, it cannot be called using the object of that class. So we have not used the scope operator. It can be invoked like a normal function without the help of any object, like we just called. They may be declared as a friend in any part, public or private, of the class. Usually they have the objects as arguments. They cannot access the member functions directly and has to use dot membership operator with each member name, like we have just seen. Okay. Next is this pointer. When a member function of an object is executed, the this pointer points to the object itself. In other words, if we call a member function of an object, C++ assigns the address of the object to this pointer and then calls the function. Thus, a member function of an object can find out the address of the object. For example, the function call a.max will set the pointer this to the address of object A. This unique pointer is automatically passed to a member function when it is called. This pointer acts as an implicit argument to all the member functions. So it will be more clear via an example. So if we see this class sample, it has a variable A, then we define that it's a public, whatever followed. So we define the display, void display function, which basically prints out that the object's address is, and we then call it as this. Then we enter the main function definition where we define sample object, and then we call the object.display. So what it will do is, because the display definition was in public, and so it will access object class will access display directly, and then it will this function will basically display the address of the object. Right? One important application of this pointer is to return the object it points to. For example, the statement return star this inside a member function will return the object that invoked it. Example 2, hash include iostream.h. So in this example we define class person, float age as variable, and then whatever is there, it's public. So person float a, so there's definition of person function which takes a float a, and then which basically assigns the value of a to age. Then it is basically person ampersandile person, scope of greater, then person dot ampersandile x. If x dot age is greater than equal to age, return x, else return star this. Next is void display, and it will print out the age. So we called void main person p1 with 40.2, p2 with 39, p3 37, and person p is p1 dot greater p3, and then we call p display and p is equal to p3 greater p2. Then again we did p display. So overall we ran 2 times display, and when we run p1 greater than p3, so it finded out like what is greater out of these, and it finds p1 is greater, so it assigns the value of p1 to p class and it displays it, so which is 40.2. and again in next exam case it checks p3 and p2, where it finds p2 is greater than p3, it assigns the value of p2 in p and displays it. So in this program the function will return the object p3 in first case, which is an argument object. If the age of the person p3 is greater than that of p1, Otherwise it will return the object p1 invoking object using the pointer this. Next is constructors. Constructors are used to initialize the objects of its class. The name of constructor is the same as the class name. It has no return type, not even void. It is always declared in the public section of the class. We need not to call a constructor, it is automatically called when we create an object of that class. It cannot be inherited and cannot be virtual. Constructors make implicit call to new and delete operators. It can have default arguments. Types of constructors. Default constructors. These constructors are used when we want to initialize some value to the data members of a class. These constructors will not take parameters or arguments. Parameterized constructor. These constructors take arguments that allow us to initialize the various data elements of different objects with different values when they are created. This is achieved by passing arguments to the constructor. Next is copy constructor. It is a constructor which is used to copy the value of one object to another. It passes the object as a parameter of the class. Both the objects should be of the same class. So if we see this example, here is a class sample which basically uses a default constructor where there is no argument. It just defines x equal to 10, y equal to 20. Then there is a parameterized constructor which takes the value of a and b and it defines x equal to a and y equal to b. Then there is a copy constructor which takes the same sample class and takes the object and it defines x is object x and y is object of y. So it kinds of just copies the values from one class to another class. So that is copy constructor. So when we run display, so in display when we print out x and print out y, okay, and then we called main function where we call s1 display, s2 display, s3 display with different values. So in s1 display it will just print x equal to 10, y equal to 20. In s2 display it gets a value 5, 6, so now it prints 5 and 6. s3 is just copy of s1, so again it's 10, 20. Okay. Next is destructors. Destructor is used to destroy the objects that have been created by a constructor. It destroys the memory allocated by the object of the class. It is automatically called when the scope of the object is over. It is also declared in the public section of the class. It takes no argument and no return types can be specified for it, not even void. Okay. Destructor cleans up the storage that is no longer accessible. So in this example, sample class exists. Inside sample there is a parameterized constructor which defines value of a and g, assigns value of a and b. Then we call destructor. So if you see, there is a tilde sample and inside that we print out by. So when we display, On display it will print the value of I and j, and when we call void main sample s1 3 and 4, so it simply displayed 3 and 4, and then it printed by with the destructor. Okay, if there are 3 objects to call display function, then the destructor function by will also execute 3 times. So here if we have called display in this example multiple times, then by will also be printed multiple times. Next is the object modeling techniques. Object modeling is a technique used to model any program or software. Object modeling languages are used to model a software. These techniques were developed as a method to develop object-oriented systems and to support object-oriented programming. UML, Unified Modeling Language, is a language to model object-oriented software. The purpose of object modeling are testing the physical entity before building them, communication with the customers, helps in visualization of final products, reduction of complexity, better chances of meeting software requirement specs. Object modeling techniques has proposed 3 types of model. Object model, this model represents the static and most stable phenomena. In the modeling technique, this model represents class associations, attributes, and aggregation and generalization. Second is dynamic model. It represents transition view of the model. It represents states, transition between states, and events to trigger transitions. Next is functional model. It handles the process perspective of the models. We can correspond it with the flowcharts. It represents processes, data store, data flow, and actors. Namespace. We have been defining variables in different scope in C++ programs such as classes, function, blocks, etc. Namespace are used to define the scope of variables. Variables, classes, and functions. ANSI C++ standard has added a new keyword namespace to define a scope that can hold global identifiers. The best example of namespace scope is the C++ standard library. All classes, functions, and templates are declared within the namespace standard. That is why we have been using the directive using namespace standard. In our programs that uses the standard library, using namespace statement specifies that members defined in standard namespace will be used frequently throughout the program. Defining a namespace. We can define our own namespace in our programs. The general form of the namespace is namespace name, variable, function, class. Example, namespace sample, double x equal to 4.5, integer m equal to 100. Void main, cout sample x, scope resolution, and cout sample scope resolution m. Nesting of the namespace. A namespace can be nested with another namespace. Example, namespace name1, x is 4.5, m is 100. Then again there is a namespace name2 where y is 1.23, and inside main function we print out cout is x. We print out x m y via name1 scope resolution x, name1 scope resolution m, then name 1 scope resolution, name 2, and scope resolution y. So if you see, we use scope resolution 2 times to access the nested variable inside the second namespace. Then we got the printout x 4.5, m100, y 1.23. Next is the unnamed namespace. An unnamed namespace is one that does not have a name. The scope of members declared in an unnamed space is global. We can access them without using any qualification. A common use of unnamed space is to shield global data from potential name classes between files. Every file has its own unique unnamed namespace. So if you see example namespace sample, it has x 4.5 m100, then again namespace which is unnamed namespace, m is 200, and in the main function we called sample x. Basically we print out sample x, then sample m, and then we in the end print out m. So if you see, then the result is x 4.5 m100, because we called specifically what is inside sample class or sample namespace, and m is the unnamed space which is called or accessible directly, so we get m equal to 200. Next is dynamic memory allocation. Dynamic memory allocation means allocating the memory runtime. Since the memory required is not known beforehand, then within that we use new operator. The operator new can be used to allocate memory dynamically, both for standard data by types int, float, long, double, etc., and also for user defined data types like structures, objects, etc. Delete operator. When a variable, structure, object created through a new operator is no longer required, the variable needs to be destroyed so that memory is freed and available for reuse. Every variable created through the new operator must be destroyed through the delete operation, otherwise a large amount of memory will continue to be allocated by the new operator, resulting in possible non-availability of memory, crash of the system, etc. So if you see main function, we print out we take the value of n, then we called pointer p, and we called new int and array n. So we keep on taking until whatever n value is defined, we keep on taking value, and then we keep on printing value, and in the end we delete the p pointer so that the memory we assigned for the int pointer gets deleted. Advantages of dynamic memory allocation over static memory allocation. Static memory allocation means allocating the memory at compile time. This memory allocation has a disadvantage, that is, if we store less number of elements than the number of elements for which we had declared the memory, then the rest of the memory will be wasted. Similarly, if we allocate less amount of memory at compile time, then we face difficulty. Dynamic memory allocation helps us to overcome this difficulty problem, as well as allow us to get required amount of memory at runtime. This is suitable for where we do not know the memory requirement beforehand. Constant member function. We can also declare a member function as a constant member function. This is to ensure that member function does not alter the value passed to it. So in this example, if we see, there is a date, define integer day, month, year, and then we define get data function which takes ABC and it assigns ABC to day, month and year. Then we define display function and we define it as constant by typing const, and then we printed out date of birth is this with day, month and year. In the main function we called date d, and then we called d get data and we assigned the values 15, 11, 1993, and again we called d display. So and on printout we get this date of birth is 15, 11, 1993. So we can declare any member function as constant member function by using keyword const after its normal declaration. Constant objects. We can create and use constant objects using const keyword before object declaration. For example, we can create x as constant object of the class date given above as follows: const date x. Okay. So we cannot alter the values contained by the constant object. This will generate compile time error. A constant object can call only constant member functions. Whenever constant objects try to invoke non-constant member functions, the compiler generates errors. So friends, this finished the first chapter of C++ programming. Thank you.